All right, greetings guys. This is a lesson about absolute value equations and inequalities. So here we go. On the calc packet, there's the questions you're going to run into. So you might say, well, this is a lot of work to get 2 questions. Yeah, but the concept is the same no matter what. So let's do it. It says here, absolute value equation, the basics. So I made up 3 questions so you totally see this real quick. There is a definite number that I could plug in for x to make this a true statement. If I were to plug in the number x equal 5, the absolute value of 5 would be 5. But wait, there's more. If you were to plug in -5, you'd also get a correct answer for this. Now, I know you're saying to yourself, well, this is too basic. Yes, these are the basics, but even the more difficult questions follow the same type of logic. So let me just get to it. Here, what are the 2 numbers I could plug in to make this a true statement? And of course, I'm hoping you would say, well, x could be either positive or -17. See, you could write your answer like this, or you could write it like this, but there's 2 answers to that. Now, here's where we run into difficulty, and it's not major difficulty, but if I plugged in 4, I will not get out -4. In fact, if I plug any number in here, and I take the absolute value of it, it will never be negative. Therefore, you can run into things that are not solvable. There is no solution, or we could say the empty set is our answer. So when it comes to the basics for an absolute value equation, you get 2 answers or you get no answers. There is another outcome that could happen, but let's look at what type of question they're asking us. They're asking us this. So let's look at something that looks more like that. But the basics are based on that. So here we go. X minus 3 equals 7. Now I wanted, absolute value of x minus 3 equals 7. See, I wanted to make up a question that was a little bit more difficult, but you know what? I know that if you really thought about it, you could guess one of your answers would be 10. I could say, you know what? I bet x equals 10 is true, because 10 take away 3 is 7. Absolute value of 7 is 7. But what might not jump right out at you as easily is this answer, -4. Because if I had -4 minus 3 more, I would get -7 in there. And if I take the absolute value of that, I get 7. So what I'm trying to get at is there is an underlying step that I'm not showing you, but that's because these are easy enough to guess. But what if they're not easier, or easy enough to guess? What are you actually doing? Well, what you're doing mentally is you're saying to yourself, you know what? If the stuff inside the absolute value bars was equal to 7, I would totally get a true statement. But what's not as obvious is you're also mentally saying, you know what? If the stuff inside those absolute value bars was equal to -7, I would also get a true statement. And then you see the light, because this top equation, it's not very hard to solve, but it is an equation nonetheless. X minus 3 equals 7, so you would add 3 to both sides. There's this answer. X minus 3 equals -7. Once again, not hard to solve, but if I did, you would get this answer. So let's step it up a notch. Let's look at this one. Well, this one is definitely not as easy to guess. I assume you could just keep guessing and guessing until you get it right, but what are you really doing? You're saying to yourself, if the stuff inside here, if the 2x plus 5 inside there was equal to 21, you would get a true statement. Or if the stuff inside there was equal to negative 21, you would also get a true statement. So when you're solving an absolute value equation, what you're trying to do is find those two results. And then, hey, over here, I'm just, going to take away 5, and then I say 2x equals 16. So what's x? X has got to be 8 over here. Or, let's separate these two. On this side, if I were to take away 5, I would end up with 2x equals negative 26. Then I divide that by 2, right? And I get x equals negative 13. So these two guys are the solutions to that equation. So you might say to yourself, yeah, but I could have guessed, I could have checked and figured it out eventually. What I'm trying to say is, warning, what if they gave you something like this? This could be very much something in your future. And chances are you are not going to guess the correct answer to this problem without, kind of torturing your brain a little bit. So just, keep in mind, there is a technique that we're actually focused on. If the information inside the absolute value bars was equal to positive 5, I would have a true statement, and I would have the correct result. What if the stuff inside the absolute value bars was equal to negative 5? I would also end up with a true statement. Over here, though, I really don't want to mess with all these fractions, so I could multiply everything here by the LCM and get it to cancel out. Oops, not equals. I'd get what? 3x minus 8, because 3 goes into 12, 4 times 2, and then 12 times 5, that's 60. And let's clean this up. What the heck? Let's finish her off. And we'd have what? 68 divided by 3. See, chances are you're not going to guess 68 thirds would be a really good answer to plug in here. And similarly, I could do the same thing over here. I could multiply all this by 12. And I'd get a very similar statement, although not the same, because right here is where it would differ. I'd have a negative 60. I'd then, finish this off, and I'd get 3x is equal to negative 52. And then I'm thinking to myself, gosh, I don't think 52 is easily divisible by 3. No, it's not. So I could just say, that the answer over here is negative 52 thirds. If you want to turn it into a mixed number, you could. But once again, what I'm trying to illustrate is the more difficult the question becomes, it's nice to know that there is one strategy technically you are using to solve any problem like this. So once again, scrolling up, this comes from your AP Calc packet. I'm sure you could find the answer to this now. Now here's the thing. Solve the inequality, sketch the solution on the real number line. So what does that mean for number 22? Because now it's an absolute value, but it is not an equation. It's an inequality. So let's talk about that. And then this video will be done, because we only have to use this technique to find the answer to 2 of the questions on the packet. So here's something I want you to look at. Absolute value inequalities have a similar concept. You can do these many different ways, but once you know how to solve an absolute value equation, this is the way I like to do this. So I'm going to just show you. Here's an example. And it's the absolute value of x minus 5 is less than or equal to 8. Well, guess what? This indicates there's going to be a range of correct answers. There are a range of correct answers. Just off the top of my head, I can tell you right now, if x was equal to 6, 6 minus 5 is 1. What's the absolute value of 1? It's 1. 1 is less than or equal to 8. So I could guess, but you know what? I don't want to keep guessing and guessing and guessing what these numbers should be. I'm going to use the same strategy I had up top. But here's how I'm going to start. I'm going to say if this stuff inside here equals 8, or if this stuff inside here equals negative 8, what I'm going to find is I'm going to find my two critical values. We call them critical values. I could add 5, right? La, 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 la. Here we go. X equals 13 is one of my critical values. Add 5, x equal negative 3 is my other critical value. And then they wanted me to sketch my answer on the number line. So here's my number line. There's 0 in the middle. Negative 3 lives over here. 13 lives over here on the positive side of my number line. This says less than or equal to. So this is that open circle, closed circle thing they told you in Algebra 1. I'm going to color that guy in. Why? Because it has the potential to be equal to it. I'm going to color that guy in. And what you'll notice here is I've broken my number line into 1, 2, 3 regions. I have all the numbers that are smaller than negative 3. I have all the numbers that are bigger than 13. And I have all the numbers that are between negative 3 and 13. So here's what we do. We do something called number line analysis, just like we did with quadratic inequalities. Let's take a look. If I pick any number in this zone here, let's just talk about this zone right here. How about the number negative 10? I know negative 10's in that zone. It's way less than negative 3. And if I were to plug it in here, negative 10 minus 5 more is negative 15. But what's the absolute value of negative 15? It's regular 15. And that would definitely not be less than or equal to 8. Similarly, I could pick any number in this range over here. And I could say, hey, what about the number 20? 20 is above 13 on the number line. And if I go to plug it in, 20 minus 5 is 15. Wait, it's 15. Absolute value of 15 is 15. Hey, that's not less than or equal to 8 either. So all the information over here is not going to be good either. What you're looking for when you're solving an absolute value inequality is you're going to have information that is either outside of your two endpoints, or critical values, sorry, I meant to say critical values, or it's going to be all the information between them. So on this one, pick any number that is between negative 3 and 13. Pick it. Hey, how about 0? It's right there in the middle there. If I put 0 in for x, if I plug 0 here, 0 minus 5 is 5. Absolute value of 5 is 5. And 5 is definitely less than or equal to 8. So this stuff in the middle here is valid. I could pick any number between negative 3 and 13. It would be valid in the original. So we can write our answer here using interval notation. We could, just to bring that back into your brain, that would be included in your answer, so that's a bracket. That's included in your answer, so that's a bracket. And this indicates all the numbers between negative 3 and positive 13. But that's not what they said in their instructions. Take a look. Their instructions for this problem on the packet says, sketch the solution on the real number line. So guess what? This is what it would have looked like. I'm going to just take all the noise away. There's 0. There's negative 3. There's 13. I would color in that circle. I would color in that circle. And it would be everything between those 2 points. So that is the type of solution they would like. This is using interval notation. And this method, this solution, is sketched on the number line. So this is what they're looking for on the packet. So let's just take a look at what could happen. See, I know that you might skip through the rest of this and say, I could do it now. What are we doing? Well, we're looking at when 2x plus 1 equals 9, or when 2x plus 1 equals negative 9. If we work this out, we're going to get x equal 4. And over here, if we work this thing out, we're going to get x equal negative 5, which represents, here's my number line, 2 locations on this number line. Should I, for this symbol, should I color in my 2 circles or leave them open? And the answer would be color them in. So we color them in, and then we go, oh, well, it's the stuff between them. Not necessarily. See, it's an inequality statement. So what happens when we solve one of these things, we end up breaking our number line into 1, 2, 3 pieces. Now, I got to tell you, the direction of the sign is going to tell us what the answer is. I actually call these innies and outies. See, this one we did right here, the arrow was pointing in towards the information. I call that an innie. What does that mean? It means the stuff between the 2 numbers is going to be valid. I call this one an outie because it's pointing out, away from the information. That's just how I visualize this or think of it. If it helps you, then you can think of it that way too. But what I'm trying to tell you is, if I pick any number in this area over here, I tell you it's going to work. How about I pick negative 10? Negative 10's in that yellow area. Let's go back to the original. 2 times negative 10 would be negative 20. Plus 1 more is negative 19. But don't forget, we're going to take the absolute value of negative 19, and that would be regular 19, which is definitely greater than or equal to 9. So I would say in this case, this stuff over here is definitely valid. Over here, pick any number. How about 10? 10's a good, big, huge, easy number to think about. 2 times 10 is 20. 20 plus 1 is 21. Absolute value of 21 is 21, which is greater than or equal to 9. So all this stuff over here would be okay. So all the information over here. And if you want to make it easy on yourself, look, plug in 0. You'll see that anything that's between negative 5 and 4 is not valid. If this were a 0, 2 times 0 plus 1 is 1. What's the absolute value of 1? It's 1. 1 is not greater than or equal to 9. This stuff is invalid. Now, on a number line, this looks kind of weird. Let me just pretty it up, but you can basically see what the answer is. This would be a 4, closed circle, and it's everything bigger than that. So we just would color it in on this side. And then over here, negative 5, closed circle. Everything less than that, so we would color everything over here in. Now, once again, this is the type of solution they're asking for in the packet. They're saying, sketch it on a number line. However, I could also say, hey, just in case you forgot, this would be how this answer would look using interval notation. Everything that's smaller than negative 5, look, there's why I have to use a bracket. There's another reason why I have to use a bracket. And remember, Mom always said, don't put brackets on infinity. So that's the answer they have, but just to keep your skills sharp, that would be the answer in interval notation. So here we go. I just have one more because I know you might have tuned me out by now because you think, oh, I got it. So once again, this guy right here, I call this an innie because it's pointing in towards the stuff. I call this one an outie, so what's this one? What's this one going to be? Is this an innie or is this an outie? It's an innie. Let's find out what two values this is between. So there's one of my statements. There's my other statement. It's going to say equals negative 14. And let's solve this. I moved the 4. I don't know if you already worked ahead of me and said the answer is 6, but it is. X equals 6 is one of my critical values. And then over here, I could do the same type of manipulation. It's very similar. But this time I'm going to get negative, 10/3 or negative 3 1/3. Whatever makes you happy. But I know that this guy right here is going to tell me, hey, you are facing inward toward the absolute value. So when you break up your number line, just letting you know, there's 0. The number 6 is over here. Negative 10/3 is over here. It's not drawn to scale, but I would put a circle to indicate that value. I would put a circle to indicate that value. But I'd look at this and I'd say, you know what? This time it doesn't have one of these. It does not. So I'm going to get rid of that, which means I leave those circles not colored in. I would leave them alone. And I'm telling you, this is an innie, so this is the type of answer I expect. That would be the answer I would find on the answer key for the AP Calc packet. But you know what? Just for kicks, if you plug in 0 to my original problem, 3 times 0 is 0. Take away 4, negative 4. Well, the absolute value of negative 4 is 4, which is definitely less than 14. So you can always check your work to see if it's right. I'm just trying to show you there are some shortcuts available to you. Okay, based on that much information, you can answer these two questions. Remember, I'm not providing you assignments to do because we're just trying to get through all this stuff. Remember, you should be able to solve all this other stuff here. We have done this in one lesson or another, but these ones now are all possible. So what about this? Let me get my greenish pen. What about this dude here? Well, guess what? That's my next video. All right. Take it easy.